Hello, in this video, we are going to look at the Desmos operations for the AP Statistics exam. We did go over this in class on Friday, but there were a few students missing, and we did have to go fast for time purposes, so I thought I'd put it in a video, and you can watch it if you have time this week. All right, let's get started. So, question number one. The principal at North High School is considering a schedule change to have lunch earlier in the day. If more than 50% of the student population supports changing the schedule, lunch will be moved to earlier in the day. The principal took a random sample of 100 students and found that 54 supported the change. The principal conducts an appropriate significance test to see if there is convincing evidence that more than 50% of the student population supports a schedule change to have lunch occur earlier in the day. Calculate the p-value for this test. So when we did significance tests in class, we were doing them out manually so that we could learn about each part of the test. This is still very important for you to understand. You need to show all your work. You need to understand the how the calculations work and what are the correct symbols to use. What we're doing in this video is we're using Desmos to go straight to the answer. This could be used to check your work. It could also be used on multiple choice questions to save you some time. Okay, so the key menu in Desmos is this plus sign on the upper left. For our first question here, we have a one sample proportional significance test, which requires a z-test statistic. So if we use the plus sign and then go to inference, we have an option for z-test and z-test for proportions. We want to use proportions, so z-test for proportions. We only have one sample, so we'll enter that sample here. There were 54 successes out of a sample size of 100. We're going to create test. We are concerned with the significance test. So first, we want to input our population proportion, which happens to be, or our null hypothesis, p is equal to 0.5, which matches what we were looking to enter anyway. But if your null hypothesis is not inputted, not the default, then you would have to change it there. Now, the principal wants to know if there is evidence that, convincing evidence that more than 50% of the student population supports the schedule change. This would indicate a right one-tailed test and calculates our p-value to be 0.212. Okay. All right, let's move on to question number 2. A curious student wanted to determine if there was a difference in the average price of a quarter-pound hamburger in the United States and Japan. The student randomly selected 15 McDonald's restaurants in the United States and 10 McDonald's restaurants in Japan and recorded the prices of the quarter-pound hamburgers. Prices of the quarter-pound hamburgers in Japan were converted to US dollars. The data was summarized in the table below. Calculate a 99% confidence interval for the difference of mean price for a quarter-pound hamburger in the United States and Japan. So we have a two-sample difference of mean confidence interval test. So again, we're going to go to the plus sign. We're going to go down to inference. Now, we have a two-sample interval test. So this is going to be a t-test. We have two samples. First, you're prompted to list the data. We actually want to click on the stats tab, and that's going to allow us to enter our sample size, mean, and standard deviation. So the United States will be sample number 1. So we have a sample size of 15, a mean of 4.53, and a standard deviation of 0.24. We can click sample 2, and this is going to be Japan, where we have a sample size of 10, a mean of 4.01, and a standard deviation of 0.38. We're going to create our test. We are interested in the confidence interval this time. You can see that it defaults to 95% confidence interval. Our question wants a 99% confidence interval, so we just have to make that change. And then we can see that our interval is displayed below to be 0.117 and 0.923. Next question. So question number 3. The heights of all adult males in Croatia are approximately normally distributed with a mean of 180 centimeters and a standard deviation of 7 centimeters. How tall must an adult male in Croatia be in order to be the tallest 5% of these males? So the key words here are normally distributed. So once again, we're going to go to our menu, our plus menu. We're going to go down to inference. And under probability distribution, it defaults to our normal distribution, which is exactly the one we need. So let's enter our mean of 180, our standard deviation of 7. We're going to create this distribution. We're going to use the menu underneath, the cumulative probability menu. It defaults to inputting the value, but what we want is we want to input the percentage. So what we would do is we would click bounds. And now I can enter my percentage in here. But first we have to figure out which way we're going to go. So they want the tallest 5%. So we want towards the right of the graph. So I'm going to click right. And then we're going to change our percentage to 0.05. And you can see that the graph changed over here, indicating the tallest 5%. And our weight or height. So our height should be 191.5 centimeters. Okay, let's go on to number 4. When playing the card game blackjack, multiple decks are used and reshuffled often so that the outcomes of the cards dealt are approximately independent. When a player receives 2 cards that are a combination of an ace and a face card, this is called a natural blackjack and automatically wins. A natural blackjack should occur 4.5% of the rounds played. What is the probability that a player plays 20 rounds of blackjack and gets 3 or more natural blackjacks? So this is a binomial distribution question. In class, we discussed passing all of the conditions, the bins conditions. So we're going to assume all those conditions are met so we can just focus on the calculator part. But don't forget, while taking the exam, you have to show that the conditions have been met. So to run a binomial probability, we are going to click our plus sign, inference again. We're going to go to probability distribution, but this time it defaults to normal, but we want binomial distribution. Here we're prompted to end the number of trials, and we are going to play 20 rounds of blackjack. And the success probability of 4.5%, or 0.045. We're going to create our distribution. Okay. And we want the probability of getting 3 or more. So we're going to once again use our cumulative probability. 3 or more is going to be to the right. Enter our value, and we get a probability of 0.059. Let's move on to number 5. The students in a statistics class want to estimate how many years it takes for a university professor to earn a PhD. They survey a random sample of 40 professors with PhDs, which results in a sample mean of 5.4 years and a standard deviation of 1.6 years. Give the 95% confidence interval for the true mean of number of years it takes for a professor to earn a PhD. So we have a one sample mean interval, and we want to, once again, because it's mean, run inference and a t-test. They prompt us to list the data. We want to click on the Stats tab. Sample size was 40 professors, a mean of 5.4 years, and a standard deviation of 1.6 years. We're going to create our test. We are interested in the interval, confidence interval. It defaults to 95%, which is the confidence interval we want. And we can see that the confidence interval is 4.888 years to 5.912 years. On the AP exam, make sure you know how to write conclusion statements for this interval. Let's move to number 6. By one estimate, 3% of Siberian Husky puppies are born with 2 different colored eyes. For random samples of 100 Siberian Husky puppies, what is the probability that exactly 3 puppies are born with 2 different colored eyes? So once again, for time purposes, we are going to just jump to the calculator part. You want to make sure all your conditions are met for the binomial distribution. So the bins and but we'll jump right in. So to run a binomial probability, we're going to click the plus sign. We're going to click inference. We're going to click probability distribution. We're going to change from normal to binomial. We have 100 Siberian Huskies, so 100 trials. Our success probability is 3%. We're going to create our distribution. We want to know the probability of exactly 3 puppies being born with this eye condition. But our cumulative probability menu does not allow for exact value. So we need to run a PDF. To do that, we would simply type .pdf and then type the number 3 in, and we will get the probability of 3 puppies, which is 0.227. Okay, so that is that answer. Let's move on to number 7. Electric vehicles make up a very small proportion of the overall car market. But by how much has the proportion increased? Independent surveys of randomly selected car dealerships were completed, and 10 of 10,000 cars sold in 2012 sample being electric vehicles, and 100 of the 20,000 cars in 2016 being electric vehicles. Calculate a 95% confidence interval for the change in proportion of the electric cars sold from 2012 to 2016. So here we have a 2-sample proportion interval. So we are looking to run a z-test statistic. An important thing to think about, especially when you're running difference of mean or difference of proportions, is how you want to subtract. Since we want to know the change from 2012 to 2016, it's important to make p-hat1 2016 and p-hat2 2012. If you happen to reverse this on the test, you will get negative values. Just change the sign on your interval. So let's begin. Plus sign, inference. We want to run a z-test for proportions. We prompted for successes. So again, we want to do 2016 as sample 1. So this is going to be 100 out of 100 out of 20,000. We're going to run a sample 2, which is 2012. That's 10 out of 10,000. Create a test. We are once again interested in confidence interval. We default to 95%, which is what we want. And the difference of proportions is going to be between 0.003 and 0.005. I can't stress it enough that it's important that you are able to write conclusion statements about this interval and understand what it actually means for the test. Okay, let's move on to number 8. According to a National Association of Colleges and Employers, the mean salary for a new college graduate is $45,327. A small college wants to know if the mean salary of their most recent graduates is greater than $45,327. A random sample of 10 recent graduates from the small college was selected, and a mean and standard deviation for those of their salary for those graduates was found. With all the conditions for inference met, a test statistic of 2.51 was calculated. What is the p-value for the test? So we are once again dealing with significance and mean, which means we should run a t-test statistic. But they gave us the t-test statistic. So this simply means that we can we can jump right to the t-distribution and find the p-value. So if we click our plus sign, you may want to be tempted to run a t-test. But this is going to prompt you for the mean and standard deviation. Now, while in the problem, they said that the mean and standard deviation was found, they don't give it to us. But that's okay. They gave us the test statistic, which is just as good. So let's go to probability distribution instead, switch from normal to t-distribution, and now they're just going to prompt you for your degrees of freedom, and we can use our t-test statistic to calculate our p-value. So the recommended on the AP Statistics exam is a degrees of freedom of n-1. So we do that. Our n value is 10, so our degrees of freedom will be 9. You want to keep the shift and scale the same and create your distribution. Under cumulative probability, it says here they want to know if the recent graduates were greater than 45,327. Our t-test statistic of 2.51 is positive anyway, so we're closer to the positive extreme for our test statistic. So regardless, either way, we're going to the right. And we just want to enter our test statistic of 2.51 in here, and we get a p-value of 0.017. Now, beyond this video, it's important to know what that means and to be able to write conclusion statements involving that p-value. Let's move on to number 9. A random sample of 95 vehicles is taken from a large parking lot in an office park. Below is the type of each vehicle and whether it is owned or leased by the driver. A chi-square test will be conducted to determine if there is an association between the type of vehicle and the method of obtaining the vehicle. Calculate the test statistic. So they tell us in the problem it's a chi-squared test statistic test, and we have multiple categories, which should indicate it's a chi-squared test anyway. The other thing to keep in mind is there's 2 types. There's goodness of fit and homogeneity and association. We can see in the problem they want us to determine if there's an association. So we're going to be running an association chi-squared test. Let's go to our menu. We go to our plus sign. We go to inference. Down here we can see we have 2 options for chi-squared. We have chi-squared for test for independence and chi-squared goodness of fit. Independence is another name for the association test, and homogeneity and independence are calculated the same way. So if you needed to run homogeneity, you could run an independence test. So let's click on that. What we want to do here is we want to enter our data values. The headers and the row titles are not important. So we'll just go 29, 20. Okay. Once we have all our data values inputted, we would create the test. Now we want to calculate the test statistic, which is going to be under significance. But let's look at the observed expected first. So in class, we spent time calculating the expected values for each cell. This is done for us in the parentheses, so you can see that what they are here. If you need to determine the contribution for a particular variable, you can click contributions, and then you can see that there's a bar graph. The darker the color and the thicker the bar, the more contribution that variable contributes. Okay, now let's answer the question. Calculate the test statistic. So let's go down to significance, and we can see our p-value degrees of freedom, and then under that we have our chi-squared value of 1.398, which is the answer to this question. Let's move on to number 10. The scores on a verbal section of the Graduate Records Examination, the GRE, are approximately normally distributed with a mean of 150 and a standard deviation of 8.5. What is the probability that a randomly selected score on the verbal section is between 145 and 160? So once again, our keywords here are normally distributed. So we're going to go to the plus sign. We're going to click on inference. We're going to go to probability distribution, normally distributed, with a mean of 150 and a standard deviation of 8.5. We're going to create our distribution. We're going to use our cumulative probability menu. It defaults to inner, but that happens to be the one we need. So we want to be between 145 and 160, and we get a probability of, or a percentage of 0.602. And that's the answer to this question. Let's do number 11. Number 11, the last question in this video. A local bakery has 2 machines for that portion cookie dough into individual servings. The bakery owner is concerned that the machines are not dispensing portions of the same size. To test this, he takes a random sample of 10 cookie dough portions from each machine, and the following results were obtained. So we are given machine A, machine B, the sample mean, and the sample standard deviation for both machines. He performs a significance test to determine whether the machines are dispensing different portions of cookie dough. Find the p-value for this test. So we have a 2-sample mean significance test. So let's go to our plus sign. Because we're dealing with mean, it's going to be a t-test. We want to switch over from data to stats, and let's type in our values. So the sample size for both was 10. The mean for machine A is 1.35 with a standard deviation of 1.10. Sample 2, he also took 10 samples from there with a mean of 1.42 and a standard deviation of 0.08. We want to create the test. We're primarily concerned with the significance test. You just want to check your null hypothesis. This is what we've been using in class anyway, so you are good. One problem that we have here is degrees of freedom. So the recommendation on the AP statistics exam is that for a 2-sample difference of mean test, you want to take the smaller sample size and subtract 1. So our degrees of freedom should be 10 minus 1 or 9. But you can see here that they're using a degrees of freedom 17.17, which will give us a value not aligned with what we did in class. Well, then why did we run this t-test significance test? Well, we can get a little bit from this. We can get a t-value of negative 1.729. Once we have that t-value, we can run a t-distribution where we enter the the degrees of freedom and go from there. So let's click our plus sign, inference, probability distribution, change it to a t-distribution. Now we're prompted to enter the degrees of freedom that we've been using in class, 9. We can create this distribution and use our cumulative probability. So we have a t-value of negative 1.729. So if we do the outer on this one, we can do the positive 1.729 and, well, actually we want to be negative there. So negative 1.729 and positive. And we get a 2-tailed p-value of 0.118. Now that we discussed degrees of freedom. Going back to the confidence interval from earlier in this video, we did not. We used the formulaic degrees of freedom for that question. Keep that in mind as you're doing mean confidence intervals and tests, especially two sample ones, where the Desmos is going to default to the calculated degrees of freedom, where we probably want the manual entry. So just keep that in mind. It's primarily a two sample mean issue, but something to keep in mind. That will be the last question for this video. If you have any questions as you're reviewing and studying, feel free to send an email and I can help you find what you're looking for.